In this video, I'm going to try and synthesize kind of what we've done in Chapter 7, part of what we've done in Chapter 8, and a fair bit of what we've done in Chapter 24. So Chapter 24 is all about using a regression model to make inferences about populations. And we have a set of data here, that body fat data. We've got the percent body fat here in column C3, and we have the weight and the waist size of these individuals. And if I scroll down, I can see that in this data set there were 20 men, and this was just about men. So the percent body fat and their waist measurement in inches. Now the example in your notes doesn't talk about weight, so we're going to leave that. Now when you are looking to find a relationship between an X and a Y variable, and you're going to use it to do predictions, etc., you're going to want to run a regression. The regression is under the Stat tab. Second one down says regression, and the very first thing we would do is to do a fitted line plot. That shows me a scatter plot, plus it actually gives me some information from the regression. Now Minitab prompts us for the response. The response is your Y variable, and on our Y-axis we've got body fat, and we're going to be trying to predict somebody's percent body fat based on the measurement of their waist. So waist is used as a predictor variable. Now in this course we are only interested in linear models, but you could use Minitab to tell whether or not your relationship is quadratic or cubic, but we're only interested in linear. Now under the Graph tab, we need to check the residual. So we go to the residual plots. We want the 4 in 1. And the reason we want to do this, your note says, if the data don't follow the assumptions of a regression, then there's not much point going ahead with it. So we want to check that straight out. All right, okay to that and okay to this. Oh, and before I go, in case there's a problem with the residuals and you want to check to see if they're normal, there's a button here called Storage. I could click in this, say OK, and here's my plots. But before I talk about my plots, notice that Minitab has stored the residuals here in the spreadsheet. All right, the very first plot we look at is the one that shows me the relationship between percent body fat and waist size. Minitab has indicated the line of best fit, and even without the line of best fit being here, this relationship looks pretty linear. I get the equation for the line of best fit. The formulas for how that's calculated are in Chapter 7. So we get a y-intercept of negative 62.56 and a slope of 2.222. Minitab also shows me in the box here what's referred to as the residual standard deviation, and it's 4.5. Now what does that 4.5 really mean? It means that on average these data points deviate in the y direction, because we're interested in the y direction. They deviate in the y direction from the line of best fit on average by 4.5, and this is going to be 4.5% of body fat, because this S value is all about the deviation in the y direction. Now it also gives us a value for R squared. We saw in Chapter 7 that that's called a coefficient of determination, and really I just want to know, what does this mean? And it means that 78.7, so roughly 79% of a man's percent body fat can be explained by his waist size, and the rest, because this should, if this was a perfect relationship, it should be 100%. The rest of this, so what's that? That's nearly 21%, is due to random error. We haven't explained it. There may be other factors that influence percent body fat, such as weight, which is why weight is in this data file, but we are not going to be talking about it. Okay, so on the face of it, this looks very linear, so I can go ahead, or at least I think I can go ahead. And then I need to look at these residual plots. Your notes say that the residuals themselves have to be normal. You have a normal probability plot here. You're interested in whether these points fall along the red line. If you are unsure of how to call this, we have saved the residuals down here in the spreadsheet, and you could go run basic statistics. I could run a normality test, and I could take my residuals, do a Ryan Joyner, and Ryan Joyner gives me a p-value that exceeds 0.1. This tells me that these data are normally distributed, or not the data, but the residuals, sorry. All right, coming back to my, oops, wrong one. Hang on now, where is it? Right. Residual plots. Okay, yeah. So I've got a normal distribution on the residuals. This one here, the residuals versus fits or fitted values, or sometimes it's called residuals versus predicted values. You want to see random scatter. You want to see roughly the same number of positive residuals, dots above that zero line, as you have dots below the zero line. No patterns, random scatter. This tells me that my variance is equal, and it also tells me that these men were picked randomly and independently of each other. If we were doing more sophisticated analysis, we would be interested in the resids versus order. Now, your textbook also talks about making a histogram of your residuals. As I noted somewhere in chapter 24 notes, I don't bother with histograms when we have small data sets because it's hard to see the shape. So really, out of these plots, I'm interested in these two right here. And they tell me residuals are normally distributed, that my variance is equal, or sometimes I call that constant variance, and that the residuals are independent. So we're good to go. Now, normally when we get a regression, and if I scroll up here, Minitab tells me what the equation is for the line of best fit, tells me the standard deviation, tells me R squared. Usually when we have an equation like this, we want to use it for prediction. So we might want to plug in somebody's waist size and predict what their percent body fat is going to be. In Minitab, you have to go to a different window to do this. So under the Stat tab, we go to Regression, and I think I may have showed you this in an earlier in chapter 7 or something, there's a video. You go to the Regression, and you want to choose this one that says Fit Regression Model. Notice down here, Predict is not available to me, and it won't be until I put something in the model. All right, this baby opens up. My response is the Y variable. The Y variable is percent body fat. And we have a predictor. The predictor is a continuous variable as opposed to a categorical variable down here. So make sure you're plugging in this second window. And we're trying to predict somebody's body fat based on their waist size. Now, by the way, in this window, you could also have checked your residuals, your 4-in-1 plot. I'm going to say OK to this. And yeah, I got that, which we've already seen. Okay, now there is information that we just got out of that second run of the regression, which we don't get from the fitted line plot. The fitted line plot, which is the information I have right here, and ignore this analysis of variance, it doesn't tell me anything or anything specific about that slope. We want to be able to use this value and make some inferences about the slope of the entire population of men. So if I come down here now to what I get when I run the regression the second way, I'm interested in this bit of information right here. This gives me the y-intercept and the standard error of the y-intercept. It gives me the slope and the standard error of the slope. In your notes, I have used these values in order to calculate a confidence interval on the slope. And notice that Minitab is not, you can look through this all you want, Minitab does not give you a confidence interval on the slope. So if need be, you have to calculate that baby by hand. Now, the other thing that we're interested in is the p-value for the slope. So there's a hypothesis run. Anytime you get a p-value, there had to have been a test of hypothesis. The hypothesis is that the slope of the line between these two variables is 0. Now, if you got a slope of 0, that implies there's no relationship between x and y. We need to be able to reject that null hypothesis. And we can with a p-value of 0, because the question to yourself is that p-value less than your level of alpha? Usually alpha is 0.05. This number is smaller than 0.05. I reject my null hypothesis that the slope is 0, and I would be able to say that the slope of the line is something that's something other than 0. And we are actually getting a positive slope of 2.222. All right. The other thing that you normally want to be able to do is you want to plug in values for x. Where does my equation go here? Hang on. I want to be able to plug in values for x, which in this case is waist size, and make some predictions on percent body fat. So to do that, we go back into the Stat tab, Regression, go to the Regression as opposed to the fitted line plot. And now that I've got something in the model up here, I'm now allowed to do a prediction. This window opens up. Minitab already knows we're running a regression involving body fat. I can enter individual values, or I could have a whole column of values if I want. Now I'm just going to put in some individual values. In your notes it talks about getting confidence intervals and prediction intervals when somebody's waist size is 38. So I could do 38. Maybe I want to do 36. I don't know. Maybe I want to do 35. You can throw in as many as you like. And we'll just let Minitab do its thing. And, well, hang on now. Let's go to results. Yeah, okay. It's going to give me the regression equation and the prediction table. I do want to see that. Say okay. Now, what do we get out of all of this? All right, there's our equation. We've said to Minitab, take an x value of 38, here it is, plug it in here, and solve for percent body fat. So this thing says if a man's waist measurement is 38, then the point that fits directly on my regression line is 21.86. So my regression says if your waist measurement is 38 inches, we predict your body fat is 21.8%. If your waist measurement is 36, we predict that your body fat is 17.4. If your waist measurement is 35, we predict it's 15.19. Okay. Minitab automatically gives us confidence intervals and prediction intervals. So what is the difference in these? Confidence intervals are intervals based on averages. Prediction intervals are intervals based on individual values. So from this one right here, I can say to myself, for all men who have a waist measurement of 38 inches, what can I say about their average, the average body fat of all men who have a waist measurement of 38 inches? I can say that I expect the mean, or that is the average body fat for men with a waist size of 38, should fall between 19.7 and 24.06%. On the other hand, if some man walks in through the door, we get out our measuring tape, we measure that man's waist. He has a waist measurement of 38 inches. Before we actually, try and figure out biologically what his body fat is, we are going to predict that his body fat is going to fall between 12.07 and 31.6%. And I can get similar information for other values that I throw in for x. So if I look at this one right here, and I look at this interval, what does this mean? For all men whose waist measurement is 35 inches, I am 95% confident that the average body fat of all those men should fall between the 12.7 and the 17.6. On the other hand, if one man walks in through the door and I measure up his waist and it's 35 inches, this is where I expect to find the body fat of that one particular individual. As your notes point out, prediction intervals are always wider than confidence intervals because confidence intervals are based on averages. Averages vary much less than individual values, and all this comes back to the famous old central limit theorem. Okay, that's it. I will be, for your last assignment, I will be posting up some problems and taking you through those problems in Minitab to show you how the regression works.